magnetic dipole. Now, we have already seen the magnetic dipole in chapter 4 and we used to write it as small m is equal to Ia. That is the current multiplied by the area of the loop. This we have seen. But in this case, what we are going to see is the actual or the real dipole of a magnet. That is again based on this Coulomb's law. What we used to say, this is the charges. So we used to say for the dipole, which we had seen in chapter 1, two equal and opposite charges separated by a small distance is called as electric dipole. The same definition applies for the magnetic dipole. So what is a magnetic dipole? Two equal and opposite magnetic charges separated by a small distance. Then we have seen the dipole moment. Okay, so this was the dipole moment, m is equal to Ia. In first chapter, E was equal to Q into 2A. So this was the dipole moment. So in the last chapter, what we have seen is the magnetic dipole moment, m is equal to Ia. The same m can also be written as Qm into 2L. And what is that 2L? 2L is the length of the magnet. If we have this as the axis, this length, this is going to be the geometrical length. We are not talking of the magnetic length here. So this is going to be 2L, just like we used to take a 2A as the length of the electric dipole. Similarly, this 2L is going to be the length of this. So let us say this can be a south pole, this can be a north pole. The total distance between the geometrical ends of a magnet, that will be taken as 2L, and each pole is going to have some pole strength, or we can say the magnetic charge, we can take it as Qm1 and this can be taken as Qm2, or we can say this is plus Qm and this is minus Qm. Because north pole is usually viewed as a positive charge and south pole is usually viewed as a negative charge. Why is so? We are going to come up in few minutes into that now. So two equal and opposite charges, that is magnetic charges in this case, separated by a small distance is called as a magnetic dipole, and the dipole moment is going to be given by charge multiplied by the length of the dipole. Then it is a vector quantity, so we have to take a vector along the length, and just like we used to say for the electric dipole moment, it is directed from the negative charge to the positive charge. Likewise, the magnetic dipole moment is directed from south pole towards the north pole. So this is going to be the direction of the magnetic dipole moment. Then how we are going to measure that dipole moment? And that dipole moment, this Qm, when we were discussing this Q was the electric charge, that was the source of electric field. But when we talk of this Qm is the source of magnetic field. So what is the source of magnetic field? What we have discussed in chapter 4, it is the moving charge. So when we talk of moving charge as the source of magnetic field, it is going to be IL. How we got this? We got it from the behaviour law. I hope you can recall this. When the current is flowing in this direction, the magnetic field is going to be in this direction. This we had seen for the behaviour law. It was Gp is equal to mu naught by 4 pi I dl divided by r square. This we have seen in chapter 4. So what is the magnetic field? Magnetic field is directly related to this I into dl. So this I into dl used to be the source of that magnetic field. So in general, what we can say I into L. So this is Qm. That is the magnetic charge which is producing the magnetic field. So how we are going to measure this? It is going to be ampere meter. Measure of magnetic pole strength. That is one word to denote this, or it is also called as the magnetic charge. So Qm is magnetic charge, or the other word which is used to define this Qm is the magnetic pole strength. It is going to be measured as ampere meter because the source of magnetic field is I into L. That is the current multiplied by the length of that current element. How we are going to measure this Qm? It is going to be A into M, that is ampere meter. Now if I want to go for this one, how I am going to measure the magnetic dipole moment? It will be measured as, this is going to be ampere meter, and this 2L is the length of the magnet. That is again going to be measured as length, that is the dimension of length. So it is going to be measured as ampere meter square. It is measured as joule per Tesla. That is another. When the electron is revolving around in the nucleus, even that single electron which was revolving around the nucleus of the hydrogen atom, even that is going to behave as a magnetic dipole. If it is applicable for hydrogen atom, it will be applicable for all the atoms. So irrespective of whatever the configuration is there of the Z and A inside the atom, that is the mass number and atomic number, all the atoms will have the dipole moment inside them. Each atom behaves as a magnet, but because the spin of electron is not restricted to the same plane. If you have got some other atom, like let us say oxygen, it has got 8 and 8, that is 8 protons and 8 neutrons as well as 8 electrons. So when these 8 electrons are revolving, are they going to revolve in the same plane? No. the spin is not restricted to the same plane. So if one electron is moving in the clockwise direction, the other electron may be moving in the anti-clockwise direction. So if one electron is going to produce one kind of a dipole, the other electron is going to create another dipole which is in the opposite direction. So the net magnetic dipole moment of that oxygen atom is going to get cancelled. So we are not going to see the oxygen atom is not going to behave as a magnet. It is rather going to behave as a non-magnet. The same thing applies for all the materials which are not going to get attracted or repelled by the magnet. If there is any configuration change or any change in the property of a material, then we are going to classify them as diamagnet, ferromagnet or paramagnet. If it is going to be lightly attracted, it will be called as paramagnet. If it is going to be lightly repelled, it will be called as a diamagnet. And if it is going to be strongly attracted, it is going to be called as ferromagnet. So those are the different materials.